We've seen the enhancements adding Xamarin to Visual Studio affords us, so let's make a new project so we can see what one looks like. If you've ever done work in a traditional Java Android project, I think you'll be right at home since it's almost identical to what you'd find in Eclipse or JetBrains Android Studio. I'm going to create a blank project which I'll call Burnt Pancake. I figured you were probably tired of Hello World, and as we all know, when you get a new stove or griddle and you make pancakes for the first time, you usually wind up throwing the first one away because you invariably burn it. So this is what I call my first project in any new environment, Burnt Pancake. That way I don't feel badly when I throw it in the trash. Having created the project, you can see that for the most part it looks like any other project in Visual Studio. This is a fresh install for everything, so you can see that Xamarin is prompting me with various learning resources. Naturally, you won't need them since you have your Skillsoft courses, but maybe it's nice to know they're there. With our new project created, we can see that even though the template was called Blank App, there's a lot here. This is what you'd get in the Java tools as a starting point for your app, and as I mentioned before, there are only a few minor differences. But let's take this step by step for those of you that have never worked with Android apps before. First and foremost, realize that our blank template did in reality create a runnable app. Most of the time in Visual Studio, when you choose a blank template, you get very nearly nothing except the project or solution structure. So this is a bit of a bonus. Let's try it out. We're going to run the app generated by the template, and I can do that by clicking the Run button as I would with any other Visual Studio project. But before I do that, I'll point out that this will build our app, then launch the default emulator. Note that the Run button is really a drop-down. This is also normal behavior in Visual Studio, so let's click the drop-down part of the Split button, and we'll see the emulators that are available. I warned you early on that launching a traditional emulator was time-consuming, and you'll get your first taste of that now. I'll pause the recording while my emulator launches. As you can see, there's not much to it. You get a traditional black Android screen, and our app only has one button. When we touch the button, the text of the button changes, and on subsequent touches, there's a counter that increments. It's a very simple app, but it serves as a starting point for pretty much anything you'd want to make. It seems simple, but there really is a lot going on here. Note the app has a title. If I click the button on the emulator to go back to the Android main menu screen, I can see that I have an icon that appears along with my app's title. Naturally, these are all things that I'll want to change or customize later. Let's switch back over to Visual Studio so we can see the files and the organization of this project, because it's actually a lot easier to build a new app once you understand how this really simple app works. Taking the project from the top in Solution Explorer, first you'll note that the project itself has a unique icon that looks like a mobile device. This is your first and possibly biggest clue that you're looking at a mobile project. You can see the properties folder that normally houses the assemblyinfo.cs file is here, as it would be with any C# app, but there's also a manifest file here. The manifest file controls the information that's used to build the app. The name of this file is required. It must be called androidmanifest.xml, so you should never change the file's name or you'll break your build. The manifest file controls a lot of information. Right now there isn't much here, just the revision numbers for the app along with the Java package name that will be used to build the app. If you've never used Java, a package is similar to a namespace in that it's used to allow you to organize classes to avoid naming collisions. Java's package rules are a little more strict than C# namespaces, but at this stage those differences don't really matter with respect to the task at hand. Arguably, the most important part of your manifest will be the section describing all of the components that make up your app. We haven't run through all of the important terminology yet, so I'll list the terms and then I'll state it with less jargon. The manifest will contain the activities, broadcast receivers, and content providers present in the application. Android as a software environment is designed to be a very loosely coupled system. Apps in the operating system itself can expose themselves for traditional object-oriented behaviors like message passing and the sharing of code and features. The manifest has a section that describes how these pieces fit together. As you build your app, more and more information will go into your manifest. In addition to what we've described so far, Android has a very robust permissions system that allows a developer to access hardware and software components on the device, but only if the user gives you permission to do so during the install. I like to think of it as going through customs at an airport. You have to declare the hardware and services your app uses, and the user of your program grants those permissions when they install your app. The permissions you request are made very clear to the end user. We'll look at how this works in detail later. For now, realize that permissions is one of the sections that will appear in the manifest file. Another important piece of information housed in the manifest is the minimum run requirements, or the minimum API level for your app. You will need to decide early on how broad a range of devices you want to support. Will you make an app that requires cutting-edge hardware, or maybe a simple app that will run on really old devices? There's a gamut here that you must decide upon during the development process and finalize your intentions by putting the minimum API level in this manifest. To sum it up, the manifest is a very important file in your app. It is literally the glue that makes the whole thing work. While we see here that the manifest is an editable XML file, it isn't strictly necessary to edit this file directly. Like settings contained in the assembly info CS file, which is pretty standard among normal .NET apps, the manifest settings can be manipulated using the settings dialog. If I go into project properties, I can see here the elements that go into the manifest. I'll just change the number, and now I can see the number has changed in the XML file. I'll change it back in the XML file, and then note that the settings dialog change has that reflected. Next, let's take a look at references Visual Studio added when we created the project. The only thing different from any other project is the mono.android library. Remember that Mono is the open source rendition of the C# language, and mono.android is the namespace used to work with Android apps in C#. Next, you'll see a folder called Assets, and there's a text file within that folder that describes briefly how assets work. This folder allows you to package assets in your app. Be careful not to confuse that with the next folder, which is resources. For now, I recommend that you ignore assets until you really need this folder. What you really want to focus on mastering first are resources. Resources in an Android app work a lot like a traditional resources file in a traditional Windows software project. If you expand the subfolders, you'll see the similarity. The drawable folder will contain things like images and icons, while values will contain string dictionaries that decouple UI elements such as label text from the UI design. This is crucial if you're internationalizing your app and intend to render your UI in multiple human languages. You can see here that the text in our Simple Apps button is coming from a resources file. At this stage, you're undoubtedly thinking, whoa, wait a minute, you skipped the layout folder. Yes, I did, because I like to save the best for last. If you love working with forms or XAML-based projects, we've finally come to your favorite part. The AXML files store your UI layout. In a traditional Android Java tool, they have a plain old XML extension. But in Xamarin Android, they use the AXML extension to indicate they are for Android. If I open this file, I see I get a designer similar to what you would see in any project in Visual Studio where a user interface is concerned. We'll spend a lot of time here later, but you can see what we have for our simple Burnt Pancake app is just a button. Let's close this and look at the last stop on our tour, the main activity file. In a Windows Form or XAML app, you have a user interface layout, a designer file, and a file that contains the code that is executed within the UI layout. The same basic idea can be seen here. Main activity contains the entry point for this program. This is where the app's execution begins. Now I'm taking it a little easy on you here because we haven't discussed in detail yet what activities are or how they work. The reality is that Android apps don't really have entry points in the way traditional desktop apps do. For now, I think it's sufficient to consider that a moot point, and think of the main activity as a convenient starting point. You can think of the activity as being a user interface elements, data, and logic all bound up together in a nice container. It works very much like a Windows Form app where you have a form, generated class that implements the form, and a code file that implements the control logic in that form. Your app may have one or more activities within it, just as many Windows apps will have many forms, screens, and other code files within it. Taken in total, the structure of an Android app isn't really all that foreign compared with other Windows UI-based projects. We have a manifest file which might be somewhat similar to an app settings file, but with a lot more responsibility. We have resources that work in a similar fashion to what a C# developer is used to, and we even have a UI designer, and what roughly equates to a form with a code behind file. All of these elements together allow us to quickly and easily create Android apps using a similar workflow found in any Visual Studio project.